You know, the technology in our cars is kind of funny, right? It's our navigator, it's our DJ, and let's be real, a lot of the time, it's our biggest distraction. But what if that same exact tech could flip the script and become our guardian angel? We're going to explore how that little device on your wrist could turn into the best co-pilot you never even knew you needed. So that brings us to the big question researchers are trying to answer. Can the very things we blame for accidents, our phones, our smartwatches, can they actually be turned on their head and used to protect us on the road?
So you've got this real paradox, right? On one hand, we all know our phones can cause distracted driving. It's a huge problem. But on the other hand, those same devices are absolutely packed with these incredibly powerful sensors. And that opens up a really fascinating possibility. What if we could harness that power, use our wearables to actually monitor our driving, and maybe even stop an accident before it ever happens?
Okay, so how do we take this idea from just a what if and actually make it real? Well, let's dive into the research that's trying to do just that, to turn your watch from a potential distraction into a digital guardian. And here's the real game changer. Think about most systems that monitor driving. They usually have to be plugged right into the car, into that diagnostic port or something. But this new system, it's completely independent of the car itself. It works using only the devices you already own, the phone in your pocket and the watch on your wrist. All right, so let's get into the nitty-gritty of how this thing actually works. It all starts with the sensors that are already built into the gadgets we carry around every single day. And that's the beauty of it. You don't need any special equipment. The system just taps into the standard sensors you'd find in pretty much any modern phone or smartwatch. You've got the accelerometer, which tracks movement, the gyroscope, which tracks rotation, and the magnetometer, which basically acts like a tiny digital compass. Okay, so the first big hurdle they had to clear was just figuring out who's actually driving. The system has to be smart enough to tell the difference between the very specific subtle movements of a driver and all the other random stuff a passenger might be doing. That's really the core challenge here. So that brings us to how it all works under the hood. How does the system take all that raw data from the sensors and confidently say, yep, you're the driver, or nope, you're a passenger? It's actually a really clever process. Really, it boils down to a pretty simple three-step process. First, the system just waits for the car to make a turn. Turns, it turns out, are the golden moments. Second, right as that turn is happening, it zooms in and analyzes the hand movements of the person wearing the watch. It's looking for that unique fingerprint of steering. And finally, it takes all that information and feeds it to a classifier that makes the final call, driver or passenger. So let's picture how this works in real life. Your phone, maybe it's just sitting in the cup holder. Its gyroscope feels the big, general motion of the car turning. At that exact same moment, your smartwatch is capturing all the tiny, detailed movements of your hand and wrist that happen right before and during that turn, the actual act of steering the wheel. And that right there is the secret sauce. I mean, think about it. When you're driving straight, your hands aren't doing much that's unique, but turning the wheel, that's a very specific, very readable motion that a passenger is almost never going to do. And that's what the researchers discovered. The absolute clearest signal of who is driving happens during a turn. So what exactly is this motion fingerprint it's looking for? Well, you can think of it like the system is asking a series of questions. It's looking at the data and going, okay, is the wrist rotating? And is it rotating like someone's turning a wheel? How fast is the arm moving? What's the radius of that movement? How long does it last? And how does all of that line up with the car's own acceleration? So it gathers up all those data points, basically the answers to all those questions, and feeds them into a machine learning model. And you can just think of this model as a digital brain that's been shown tons and tons of driving data. It's learned to spot the incredibly complex patterns that scream steering versus the ones that say, just reaching for some chips. And based on those patterns, it makes its final decision, driver or passenger. Okay, so the theory sounds great, right? But an idea is only as good as its results. So how well does this thing actually work out in the real world? Let's take a look at the numbers. The big headline number is honestly, it's pretty staggering. We're talking 98.9%. So to be clear, that means it was 98.9% accurate at correctly identifying the driver just based on the data from a single turn. That is a ridiculously high level of confidence. But what about the tricky situations? I mean, what if the passenger is doing something that could confuse the system? Well, they tested that. If a passenger was just sitting still or on their phone, boom, 100% accuracy, no problem. But even when a passenger was eating snacks, which involves a lot of complex rotational hand movements, the system still nailed it with 96.7% accuracy. That's impressive.
And it's not just accurate, it's also incredibly fast. On average, the system figured out who the driver was in just over 21 seconds after the trip started. I mean, that's basically the time it takes you to pull out of a parking space and make your first turn.
So, okay, the system is crazy good at knowing who's behind the wheel. But believe it or not, that's really just the starting point. Let's talk about the road ahead and what this technology could mean for the future. This is where things take a huge leap forward. Once the system confirms you're the one driving, it can use that exact same sensor data from your watch to estimate the actual turning angle of the steering wheel, and it gets it right with an average error of just a few degrees. And the way it pulls this off is so clever. The system is smart enough to know that your wrist doesn't rotate in a perfect one-to-one match with the steering wheel, right? Your wrist bends and flexes. So it actually creates a custom mapping profile to correct for that bend, perfectly translating your watch's movement into the wheel's true angle. And this is why all of this matters. Being able to know the steering angle, again, with no connection to the car, it unlocks this whole world of potential safety features. We're talking things like lane departure warnings, detecting if a driver is swerving unsafely, or even picking up on the subtle, erratic steering patterns that can mean someone is drowsy or distracted.
Which brings us to a final and kind of heavy question to think about. This technology is incredibly powerful, no doubt. It could literally save lives, acting like this little co-pilot on our wrist. But it also opens up some big questions about our data and our privacy. If your watch knows you're driving unsafely, who should it tell? Just you? Or maybe your insurance company? Definitely something to chew on next time you get behind the wheel.